In this session, we will discuss about types of data structure, what is an array, what are the types of arrays. This is the first half part of the second unit. What is a data structure? I have given a good introduction for the data structures and examples for the data structures also. So let me revise that. Data structure is a method of collecting and organizing the large amount of data. So if you want to store the large amount of data, suppose it might be some complex data, otherwise it might be some network elements, otherwise some hierarchical data elements are existed, then even though by using the data structure we can efficiently collect the data and organize the data, we can map the data, and we can also make the different kinds of operations upon your large amount of data. What kind of operations you can make? That might be some searching, otherwise some sorting the elements, otherwise you can insert a new element, otherwise you want to delete an element, you want to traverse, nothing but you want to check to see all the elements existed in your data structure. So this is the basics of data structure. And what is a data structure and its types? There we have the two kinds of data structures. One is linear and second one is the non-linear data structure. Let us start about our linear data structure. What is a linear? Linear data structures are it's a sequential process of traversing. Nothing but suppose if you want to check the particular element existed in your data structure, so if it is possible to traverse the element in sequential nothing but arrays supports the continuous memory locations. So by the continuous memory location you can sequentially line by line, suppose the location will be start from 0 up to the n-1, we can move from 0 location, first 0 index, first index, second, third up to the n-1 locations we can search, otherwise we can traverse. So linear data structures provides the traversing the data elements sequentially. We have to remind one thing, that sequential process will be possible by the linear data structure, sequential data traversing. You don't know, you might be know about the traversing. What is the traversing? Traversing is the process of visiting all the data elements in the data structure. Suppose I have an array of some 10 size, I want to see all the elements from 0 location to the up to the n-1 location. So nothing but we want to display all the elements. If you want to see the elements existed in your data structure, that is called the traversing. Okay, in linear data structure only one data element can be reached directly. Suppose I want to check the 5th location of an array, nothing but we can directly reach the particular location, particular index of an array. So in the linear data structures we have the different types. Those are arrays, linked list and stacks, queues. So in the first session we will discuss about arrays, and next sessions we will start the linked list. In the third unit, stacks, queues, all these will be existed in your second and third units. So what is an array? So in this session we will discuss about arrays. So basically what is an array? You know about what is an array. Array is a collection of similar data items. Similar, otherwise it provides the continuous memory locations. Homogeneous types of elements will be stored in an array. Okay, so every array element is referred by a subscripted variable. Subscripted nothing but it might be some index. Okay, every element will be located, nothing but if you want to check particular location, by what we are searching? By the index we are specifying the particular location of an array. So we need the value is called the some subscript or index enclosed in a parenthesis. And next, what is a linked list? Linked list is nothing but linked list is a collection of data elements, just like arrays. It is a collection of elements, but it contains every list. It consists the collection of lists. What is a list here? A list is a some data element, nothing but it contains two parts. A list contains two parts. Each list having one is information part and link part. So every list contains the information part and link part. What is information? Information is nothing but some data value, otherwise some data element. It might be any kind of data. Okay, you know the different kinds of data types. It might be integer, float, some character. So what kind of data it is? That is the first part, data part. And next is the link. What is the link? Link is nothing but what is the next list address. Nothing but link is an address of the next node. Nothing but next link. Okay, what is that? We will discuss later. But by using the linked list also will make the collection of data of the data items of the similar type. So by the arrays we are implementing some continuous locations, okay, but by using the linked list we need the help of pointers. How is it? We will discuss in the next part of this second unit. Next, what is the stack? Stack is a linear list of elements. One thing we have to remind: arrays, linked list, stack and queues, all these will be come under the linear data structure. All these will be stores the some collection of similar items but having the different properties. Okay, so arrays having the some linear continuous location allocation, linked list having the collection of data items of different links will be connected to the one every link. Okay, and next, stack. What is a stack? Stack is also one of the linear list of data elements. What is that? So how the data will be stored? Stack is also one of the linear structure. So in that we can insert the elements, we can delete the elements. So how can we do all these operations? So every data structure having its own operations, ADTs, abstract data types. So what are the operations? Some insertion and deletion. So nothing but by the data structure we are storing some data into the memory, we are deleting some elements, we want to make some searching and sorting. So in the stack we can insert and delete the elements at the same end, nothing but at particular end, particular point of place where we have to insert and delete, that we have to know, we have to call as a top. So we have to call the insertion operation is the push function, and if you want to delete nothing but to remove an element from the stack, it is a pop function. So we will discuss all these in detail. I have already sent the stack structure before the records. Okay, and this stack is also called as the LIFO, last in first out. The property of the stack is the LIFO. At the same time we can call it as the FILO. FILO nothing but first in last out. So next, what is the queue? Queue is also a linear list of elements. So in this also we will collect the data at the linear fashion data structure model, and in this we can add the element from one end and we can delete the element from the another end. So nothing but at the stack, before the structured stack we are inserting and deleting at the same end, but here we have the two ends, one to insert and one end to remove. From the rear we can insert, from the front we can delete, nothing but we can remove. So all these will be discussed. These are the essay questions. Stack is one of the essay question, queue is the one of the essay question. So we will discuss in detail in the third or second units. What is a nonlinear data structure? So what is a nonlinear data structure? So what is a linear data structure? Linear data structure provides some sequential traversing. Okay, we have to remind one thing: linear data structures provides a sequential data traversing, continuous data storage. But here it is opposite, nothing but in non-linear data structure, what will be happen here? The data values are not arranged in order, nothing but these are not in sequential arrangement, and the data is connected to serve other data items, nothing but we have the collection of data elements, but these are not stored in a continuous location, even though we can connect all these data elements. And if you want to add new element, it is possible. If you want to remove particular element, it is possible. So these will be developed by using some dynamic memory locations, nothing but using pointers. So the difference is that in the linear we have stored in sequentially. Here these are not arranged in order, nothing but not in sequential fashion, but we can link up all the data elements, nothing but we are connecting the data data items to serve the other data items. Okay, so in this nonlinear, what are the types here? So we have the trees and graphs. What we have? Trees and graphs. What is the tree? Tree is one of the non-linear, nothing but, so these are not sequential, otherwise linear data elements. So these are very flexible and versatile, nothing but, so flexible and versatile, nothing but, and at any point we can insert, at any point we can remove, if these operations will be if necessary. Okay, so these are flexible, versatile and powerful non-linear data structure, because these are represent some process, some hierarchical relation, nothing but some parent-child relationship, otherwise to make some relation between some complex data elements. Okay, just like parent and child relationships will be done by using the trees. Okay, so how will be these will be discussed in the coming sections, but we have to learn what are the types of non-linear data structure. In the trees we have to learn one thing, that these are non-linear and making the some dynamic memory allocation and efficient memory management, and at any point we can flexibly we can insert easy to remove the elements. So these are the some hierarchical representation, hierarchical relationships will be possible by the trees. And next one is the graphs. What is a graph? This is also one of the nonlinear. So to make some dynamic memory allocation, to make some data with the some collection of data elements, these will be paired, nothing but connecting, just like graph. So which consists of a from finite set of ordered pairs of edges nothing but some one data element is existed and other element data element is there. So how to make the relation? By the edges, some links. So graph is a set of data elements connected by the edges, so each element is called as a node. Each element called as a node. Node is nothing but we have to done by using either linked list or arrays also. Node is a data element. Okay, so trees and graphs are the non-linear to make the data management and efficient memory storage, nothing but we no need to waste the memory, because by the arrays it is a stack nothing but arrays will it might be waste the memory, because if you have declared some 50 size of array, so we might be used or may not be used. So in this case the memory might be waste, and sometime if you want to add the some more than 50 size, it is not possible by the static array size. But by using this nonlinear data structure, we can add the new data, we can remove the data at any point by the flexible memory management, nothing but we can add any data node at any point of time, we can remove the data, and by the graphs and trees we can make the some hierarchical communication. Okay, hierarchical communication, so making the some edges connecting the data elements one to one. Okay, all these will be possible by the non-linear data structure. These are more helpful than the arrays. Even the arrays are more useful, maximum operations will be done by using the arrays, nothing but suppose I want to search a particular element, I want to sort particular elements, so all these will be maximum usage done by using the arrays, even though, but trees and graphs very helpful and with the help of dynamic memory allocation. Okay, these are the introduction for the arrays. Next, what is array? So next part we have to learn about arrays. I think maximum you have learned about arrays. What is an array? What is the declaration part of an array? How to represent an array, and what are the types of an array? So these will be discussed, because in the second unit we have the particular topic here that only we are discussing, and this is the completely for your notes also. For this case only I am giving the notes. Okay, so I am giving the link also. This document notes also given. Okay, introduction to the arrays. What is an array? Arrays already we have discussed. Array is one of the linear structure. So the memory will be stored. The memory will be allotted in the some homogeneous data elements at the continuous location. Continuous memory locations, nothing but some sequential memory storage will be done by using the arrays, and it provides a direct access to at any point of particular location and to any of its elements. At any point of location, at any point of place, we can insert and particular make some operations upon the array data structure. And what is the size? Size nothing but I want to store particular some 50 size of elements, so we have to specify the size. So before you are storing, we have to specify the size. In the non-linear data structure, we no need to specify the size. We can go and insert any number of data elements, n number of data elements at any point. But in the arrays, we have to specify the size. This is the mandatory. Okay. Next, these are the basic representation. What is the representation? So we have an element and index. What is an element? Suppose I have an array, some f float type of array. I have given example here. F is some element. Each item stored in an array is called as an element. So f is an array. The values will be stored in the location here. So see the down example here. Suppose I have created f array of float type, some size, some 0 to 9. Index will be called as a some f of 0, f of 1, f of 2 up to f of 9. So every element has an index. So element nothing but in the array what is the data will be stored. Next index. Index nothing but each location of an element. Each location of element. Suppose fourth location is the f of 4. The value is the 2.2. Okay, so f of 4 value is the 2.2. So index by the index we can make the operation. We can go through the array. Okay, by the index we can make the operation. We can traverse the elements existed in your array. Okay, so element nothing but what is the data element, and index specify the each location of an element. Index nothing but the index will be get started from the 0 to the n minus 1. So by the index we can make the operations upon your array. And next we have to definitely specify the size of an array. Nothing but here f of 10 can be stored up to 10 values. If you want to make more than 10, it is not possible. So if your might be used 10 or not. Suppose I have declared 10, but I mightn't be used all the 10 values. So if I have used 5, the remaining 5 size will be wastage. So the here one drawback we have to observe here, that wastage of memory is existed in the arrays, because we are fixed the size. Initially we are making the size is fixed. Okay, so what are the array types? What are the array types? One dimensional array, what is that? One dimensional 1D arrays, nothing but one dimensional array. What is a one dimensional array? It's a type of linear data structure, and it will store some array of elements, just like some row of elements. You know what is a single one dimensional array? Okay, the syntax we get here, the syntax is what is the data type of the data, array name, and size of array. Example, float of f some 20. So before example, the picture I have shown, this is simply called as a one dimensional array. This is the one dimensional array. Some 20 nothing but some 0 to 19 index. Next, what is a two dimensional array? This is also we have discussed, but in the syllabus we are going through like that. In two dimensional array, it's a list of one linear and nothing but one dimensional arrays. Nothing but some rows and column fashion data will be stored. So how it will be possible? So look at the example I have given down. So it's like just like tabular data. So I want this is very simple example. Is for example for the matrix operations. I want to make some 2 by 2 matrix, some 10 by 10 matrix. So this kind of rows and column operations will be done by using the help of our two-dimensional arrays. So example for the two-dimensional matrix operations. So what is the syntax here? Syntax I have given what is the data type and size of array, and how the data will be represented here. Rows and columns, some row size 0, 1, 2. Here I have given example A of some 10, but I have used only some 0 to 2 size. 0 to nothing but 3 by 3 matrix. So in the diagram I have shown some 3 by 3 matrix. So 3 by 3 nothing but 0 to 2 0 to 2 rows and 0 to 2 columns. Okay. Next, what is the n dimensional array? What is n dimensional? Nothing but multi-dimensional array. Multi-dimensional nothing but not only the rows and columns. If we want to make some data, some arrays of arrays are n dimensional arrays. So nothing but more than 2, nothing but 3 or more dimensions will be existed in the n dimensional array. Nothing but look at the syntax I have given here. What is the syntax? Data type, array name, some size 1, size 2 up to the n size. N number of nothing but n dimensional array, n size we have to given. So example, suppose it might be 3 dimension, more than the 2, nothing but 3 or up to the n size. N number of size we can specify. This will be helpful for the mathematical operations. So basically we have to know one thing, dimensions are nothing but one dimensional array, two dimensional array, and otherwise n dimensional array. Maximum matrix operations and more mathematical calculations will be done by using the n dimensional arrays. Okay. Next, what are the ADTs? Abstract data types of the arrays. Abstract data is nothing but what are the different kinds of operations upon the data. These are the different operations upon the data. Nothing but ADTs. ADTs are the different operations performed upon your database, data elements. So what are the different operations? It might be traverse. Traverse nothing but visiting all the elements existed in your data structure. Okay. Traversing array and access the data elements. Traverse nothing but visiting, and we can make some operations upon the data. Operation nothing but to make the access, to make the if you want to print the element, if you want to search all the elements existed or not, what are the elements existed. So all these will be existed helpful for the traversing the data. Next, insertion. Insertion nothing but, you know that nothing but if you want to add an element into your data structure. Okay, here our data structure is array. So particular location into the particular index if I want to add, so it is possible by the insertion. Nothing but before classes in the C also we learn nothing but how to insert data elements into your array. How to insert your data elements in your array. And if you want to delete particular element, how can we delete? I want to erase the particular element, so these will be done. And search, I want to search a particular element in the particular index. Suppose I have the students of from 100 to students, I want to check who is 50 number student, so it is possible by the search operation. In the update nothing but update an element at a given index. Suppose in the 50 student his name is changed, otherwise he might be transferred. So how to make the changes? By the update operation we can make operations upon the particular index. Next example, a simple example I have given. One example for the one dimensional array, and next is the two dimensional array. In one dimensional array and two dimensional, I have given a simple example for the total elements existed in the array, one dimensional array and two dimensional array. So we can understand this example. I have already explained these and practice these also, and at last we have to learn that what are the advantages of the arrays and disadvantages of the arrays. We can understand that what are the advantages. Arrays permits the efficient random access in constant time. Okay, it provides the efficient access at the particular index of an array at the particular constant time of the array operations. Next, these are more appropriate for storing a fixed amount of data. So array is basically a static data structure. It provides some fixed amount of data. Fixed amount of data nothing but if I have created some 20 size array, so it is fixed. Nothing but data will be, we can store up to the 20 size elements. So data retrieval can be possible directly. Okay. Next, it's a more compact data structure. Nothing but at any point we can insert and we can go to the particular location. Next, these are well known in applications such as searching, sorting and matrix operations. Nothing but suppose every searching and sorting operations and matrix operations will be take the help of the arrays, and these are represent some strings. You know what is a string? It's a collection of characters. So every character will be, suppose if your name is stored in the memory, nothing but some particular 4 or 5 characters, all these will be should be in a continuous location, homogeneous elements and continuous memory storage. So arrays are used to represent the string and some stacks and queues. So even though these arrays also having some disadvantages. One thing we have, array is a static structure, so we cannot extend the size, we cannot remove the particular size. Nothing but second point here, arrays are of fixed size. If you want to extend the size, it is not possible. If you want to remove particular size, not possible because it is fixed. So if I have used 20 size array, even though I apply only 10 size, the remaining 10 size is wastage. So if you want to create some more than 20 extended size, nothing but if I want to add some one more element, 20 plus 1 size, 21 size, it is not possible. So it is fixed, and these are inefficient because, so for the insertion and deletion operations will be not possible. I already told that this is the fixed size. So array is inefficient for the applications that often need some insertion and deletion operations in between these. So if you want to make some transaction, extending the size, removing the size, these will be the drawbacks of the inefficient memory management. So only thing is the static, that so fixed size is the problem here. So then only arrays are having some this kind of static management disadvantage. Even though maximum we have to use the arrays for the matrices operations, stacks and queues, and some sorting and searching. So all these will be taken the help of the arrays. Even the arrays are very helpful because these are the sequential storage, continuous memory location, and having some fixed size. Okay, so different kinds of searching and operations will be done. Even though it is a static, the drawback only that it is static. So because of that we cannot dynamically insert and delete. So it has a fixed size. There is a fixed size that we have to specify the size initially. It should be mandatory. In the non-linear we don't need to specify directly. Okay, these are the basics of the types of data structure and arrays. In next session we will discuss about pointers and pointers in operations.